Hi, this is Sikandar Rafiq and you're watching DevCore Learn Software Development channel. So in today's video we will discuss what is DBMS and what is RDBMS and how it can be and why it can be used in software development. So this is very essential video, so don't miss to watch this. Okay, let's go into the topic. What is the DBMS? So database management system is the software used to store and manage and organize and retrieve the data efficiently from the database. So basically it is the interface between the database and the application. So if we discuss this, okay, this is our application, any software, web or desktop application. So it is using the DBMS, right? RDBMS, for example Postgres, which we are using in this tutorial, and here beneath the database, right? So application is here, and application is using the RDBMS. RDBMS is the software used to manipulate the database for insertion, update, deletion, and fetching the data from the database. And through this application, it is fetching the data from the database and provide this data to the application in different form, in the form of cursor or in the form of records. So this is the whole concept. So basically it is the interface. So real world example is the banking system. So banking system need to store the information, customer data, account balance, transaction data. So by using so all the information we are saving here in this database, and by using the RDBMS, which is the software, our application, website or web application or the desktop application will fetch the data from the database by using the Postgres. So it will provide the data to our application. Okay. The next we will discuss the popular DBMS types. So Postgres, MySQL, Oracle, MS SQL Server, or these are the relational databases. These are using the tables which has the relationships to each other, right? So these are called the relational database. There is another database which is the DBMS, which is called the MongoDB. So MongoDB is basically a NoSQL database. So it is not using the relation between the tables. It is using different formats. It is saving the whole data in the form of documents or etc. So okay, why DBMS used in the software development? So first one is data storage. So as you have seen, we are saving the whole data in the database and easy retrieval of the whole data. So we are using the SQL commands. For example, we are using the SQL command, select static from users, so this is one SQL command which is fetching the data from users table, right? So it can be enhanced by using the where clauses, add order by clause, and then joins with the other tables as well. So we will discuss the complex commands in more detail in the next videos. So this is the easy retrieval through DBMS. DBMS provides the routines, SQL commands through which we can retrieve the data. Data security. So we have already discussed in the previous video. So data is secure and it can be controlled through the permissions and access controls. So each user can access the data, so based on the authentication and authorization. So I will repeat this concept. Authentication means user is logged into the user by using the credentials. So no user without the credential cannot be allowed to enter the application. And then authorization. Authorization means rights-based role-based access or rights-based access. So if some task is not authorized to specific user, then it is not allowed. For example, admin user can upload the media file or do any other task, but normal user cannot do these tasks. So these are the security, data security. Another data security concept is, for example, the strong database, just like the Postgres, it provides the row level security, right? So if you are not row level security, if some user is not allowed to access that row, then it cannot be accessed that row. So it is very powerful feature of the database, Postgres database management system. So different database, DBMS has the different features. Data consistency we have discussed in the previous video as well. So data should be accurate after the each transaction. Just like we have given you the example, if some one credit should be transferred from the one account to the another, so it should be atomic transaction. It should not deduct from the one account and don't add to the other account. So it should be atomic. If one account is deducted, then it should be a credit to the other account as well. Multi-user support. So user hundred of thousands of user can use, for example, n1 to n, and n is a number for maybe it's for 1 million or 100,000 or maybe more. So n number of user can access the database through this application. So this is the multi-level support. Okay, transaction management. So after the each transaction, data should be accurate and valid. It is logically accurate and synchronize the whole data, right? So DBMS we will use in the backup and recovery. So different types of errors comes in, and we have lost the access to our DBMS software. So different DBMS software provide the recovery and backups. So for example, if one user is taking the backup to each day at 12 AM each day, so if there is some failure of the system, then it can be recovered from the backup. The other concept is very strong databases, just like the Postgres database, provide the master-slave concept. So one user is the master and other user are slaves. If some master user is down due to some error, then one of the slave user is upgraded to the master level. So in this way it has provided the long-term accuracy, long-term access to DBMS. Reduce the data redundancy. So it reduces the DBMS reduces the data redundancy due to the primary keys and the data integrity, the foreign keys, and the constraints and rules. Constraints and the validation rules. So that the unnecessary data and redundant data will be removed. So we will normalize the data. We will discuss normalization in more detail. So to remove the redundancy between the data. Better performance. So DBMS is used for the better performance. For example, if we can use the index any data. For example, if there is a table, users table, and we want to search the data based on the name, user name, user ID. So we will index this data. So searching based on the name will be more fast. So another example, for example, we want to search based on phone number. We can index this field phone number as well. So there is a two-way we can index this, and we can make it the child table as well. So we will discuss how we can make it the child table to search phone number very efficiently. So this is for the better performance. We can index the data. Another thing is we can optimize the query optimization. Query optimization. We will optimize the query so that we will retrieve the data very efficiently. So indexing is used for better performance, query optimization, and there are a lot of other techniques as well for improving the database performance. So we will discuss in more detail in the next videos. The role of DBMS in modern application. For example, different type of application, almost all the software are using the database. So banking apps, data saved is accounts data, transactions. E-commerce application save the products and orders, payments, and other data. Social media app save the post, users, messages, comments in the database. Hospital systems use the patient data, reports, medical history, etc. So all these and retrieve based on the requirements. WhatsApp like application, chat chats, contacts, and the messages, etc. Okay, difference between the database and DBMS. So database is the collection of data, and the DBMS is the software used. For example, here you can see this. So this is the database here. This is database, and DBMS lies in the application level. So application uses the RDBMS to fetch the data from the database, right? So all the data is stored in the database, but application use RDBMS to fetch data from the database and provide it to the application. Database store the information. DBMS is the controls, access and operations. So already we have discussed the authentication and authorization. Database example is the student records, and DBMS example is the Postgres database, SQL or MySQL. How software uses the database? Step 1 is the user signing on the website or any desktop application. So backend receive the data from the user data from the application, and the next step is data stored in the database, and the fourth step is data becomes permanently stored. So in this way data is stored in our database. What is the RDBMS? RDBMS stands for Relational Database Management System. Is a type of DBMS that stores data in the form of tables and manages relationships between those tables. For example, data stored in the form of tables, rows, columns, etc. So RDBMS example is, for example, we have the student table. Okay. We will create the student table here. Okay, student ID, student name and department ID. Which department the student, for example, one student name is Ahmed. We create the department table as well. Okay, here is the ID and the department name. For example, one is the for CS, two is for software engineering, three is for any other program IT. So M, for example, belongs to here 1. So 1 basically refers to this report, right? So basically it is used as foreign key here, foreign key, and this is the primary key, right? So these are the relationships between student table and the department table. Another example is, for example, to Akram, and it belongs to department number 2. 2 so belongs to 2, it means software engineering, right? So in this way you can see the student table is linked with the department table. So this is the relationship. So it is through by foreign key, right? Why it is called relational database? Because it relates to each other through the primary keys and foreign keys, and this creates the relationship between the data. Or if you can see again, student table, and so here you can see, so student table is linked with the department table through this foreign key. So in this way, we have the different tables have the relationships with each other, right? So that is why we will call it the relational database, DBMS management system. RDBMS features, it has the table-based structure, right? We have seen we are creating the tables here, strict schema-based relationship between the tables. We have seen the relationship between these tables. So RDBMS uses SQL command to fetch the data or manipulate the data, insert the data in the database, or update the data, or delete the data. Data integrity we have discussed in detail in the previous video. So data integrity is maintained through the RDBMS software. We have seen many different types of data integrity, entity integrity, then differential integrity, and then we have seen the domain integrity and business user defined integrity. So multiple user support. So each database can support the hundreds of thousands of users. So this is the RDBMS feature. Supports constraints. We can define the constraints, different levels of types of constraints. For example, name should not be okay. So for example, the table name should more than 5 characters, or any other constraint. For example, email must have the @ and something like that. So different types of constraint we can apply on the database. Different between the DBMS and RDBMS. DBMS is a general database management system. Relational database management system. So RDBMS means it has relationships between the tables. DBMS may not have relations, and RDBMS support the table relations. DBMS store data in the various forms. For example, it stores data in the form of documents and column, key, value pairs, and it stores data in the tables. Less strict integrity, but RDBMS has very strong integrity constraints. For DBMS example is the file system or NoSQL database as well. For RDBMS is the Postgres, which we will use in the coming videos. So in this video we have discussed the DBMS and what is the RDBMS and what is the relationship between these tools. So in the next video we will install the Postgres database, and we will install pgadmin tool to view the data. So keep watching. Thank you so much for watching the video. Until next video, bye bye.